Hi, it's Ms. Trevino again, and I'm going over the Unit 6 portion of your 2020 Physics Midterm Study Guide. I've already went over the Units 1 through 5 in the early videos, so if you need help on those, make sure you check out the early videos. Number 56, what is momentum? So momentum is any object with motion. It has to be moving to have momentum. If there's no motion, there is no momentum. Number 57, what is impulse? Impulse is a change in momentum. So if the velocity changes, if the force acts on it, if there's some new acceleration, then we're changing our velocity, we're changing our motion, so we're changing our momentum. Number 58, what is the force of a bike with an impulse of 30 Newton seconds and a time of 15 seconds? So we have our impulse, Newton seconds, that's our impulse. Time of 15 seconds, that's our time. We want to know the force of the bike. So we have impulse time, we're looking for force. We're going to use our impulse equals force multiplied by time form, but we're going to have to rearrange it. So impulse is force multiplied by time. When you plug in your numbers, force is 30. Impulse is 30. We're looking for our force, and our time is 15 seconds. So when you're solving this problem, all you have to do is divide both sides by 15. That cancels out over here. So 30 divided by 15, that is 2. So your force is 2, and the units for force are newtons. Number 59. The ball in the diagram is moving with a speed of 23 meters per second. What is the momentum of the ball in kilograms meters per second? So we know the speed, which is the same thing as velocity. We're looking for momentum. And we know our mass because in the picture it says 0.20 kilograms. So we're looking for momentum. We have mass and velocity. We're just going to use our very first formula. Momentum equals mass times velocity. So P equals mv. When you plug in your numbers, we're looking for momentum. Mass is in kilograms, 0.20. Velocity is in meters per second, 23. Now you just multiply 23 by 20. Your momentum is 460. And the units, it tells you the units in the problem actually. It's kg meters per second. That is our momentum. Number 60. A 1.2 kilogram block and a 1.18 kilogram block are initially at rest on a frictionless horizontal surface. When a compressed spring between the blocks is released, the 1.8 kilogram block moves to the right at 2 meters per second as shown. What is the speed of the 1.2 kilogram block after the spring is being released? So this sounds to me like it's a collision problem. We have 2 blocks at rest on a frictionless surface. Then a spring between them is pushing them apart. So they're together, then they are pushed apart. So this is going to be a recoil, which means we're going to be using our recoil formula. M V, oh, I'm sorry, that's not recoil. Mass plus mass times the initial velocity is equal to the mass times velocity of the first object plus the mass times velocity of the second object. So I'm going to use some highlighters so I can know which one's going to be my first object and which one's going to be my second object. For my first object in the picture, I'll use 1.2 kilograms. And then for my second object, I'll use the 1.8 kilograms. So in my problem, I have a 1.2 kilogram block. That's my first object. And a 1.8 kilogram block. They are initially at rest. So when I plug in my numbers, I have a 1.2 plus a 1.8, and it's at rest, so it's 0. Then a spring's compressed, and then the 1.8 kilogram block moves to the right 2 meters per second. I want to know what the speed is of my 1.2 kilogram block. So when I write this out, I have my 1.2 kilogram block with a speed of, I don't know, that's what I'm trying to find, plus my mass of 1.8 times the velocity of 2 meters per second. Now I'm just going to solve using algebra. 1.2 plus 1.8 is 3, but it's multiplied by a 0, so that cancels out because 0 times anything is 0. I still have 1.2v, and then 1.8 times 2. That's going to be 3.6. Now, using algebra, this would be a 0. So I have to remove 3.6 and bring it to the other side. And I'm going to do that by subtracting. Because it's being added, I need to do the opposite. So when I do that, that cancels out. I'm left with negative 3.6 equals 1.2v. Now I just have to divide both sides by 1.2. Negative 3.6 divided by 1.2. That gives me negative 3. So that's saying my velocity is a negative value. It's negative 3. Is that possible? Yes. All a negative velocity means is that I'm moving to the left. I'm moving this direction. Which makes sense because in my problem, my arrow is pointing to the left. So yes, this is correct. Our last questions. Number 62, the diagram above represents two masses before and after they collide. The 8 kilogram mass is moving at 60 meters per second when it strikes the 20 kilogram mass at rest. Upon collision, the two masses stick together. What is the speed of the combined masses after the collision? So again, it sounds like we have a collision problem, but it says they're apart, then they stick together. So that tells me that this one's going to be an inelastic collision, which means I have the mass and velocity of my first object plus the mass and velocity of my second object equal to my two masses added together multiplied by their shared velocity. So I'm going to use my highlighter again. I'll have my 8 kilogram mass moving at 60 meters per second as my first object. Then it's going to strike a 20 kilogram mass at rest. So when I plug in my numbers, I have an 8 kilogram mass times 60 plus my 20 kilogram mass times 0 because it's at rest, which cancels out because 0 times anything is 0. Then I'm going to add my 8 kilogram mass plus my 20 kilogram mass, and I'm going to find out their velocity. So 8 times 60, that's going to be 480. 8 plus 20, that's going to be 28. B. Now to solve this problem, I'm going to have to divide both sides by 28. So 480 divided by 28, my velocity is going to be 17.14. It's positive, which means it's going right, which in the diagram it is, so I know I did it right. Number 63, the pictures show how an airbag functions in a collision. How much momentum in kilograms meters seconds does the airbag absorb from the crash test dummy if the entire crash test dummy's momentum is absorbed by the airbag? How does the airbag help decrease the force felt by the driver? Remember, force times time equals a change in momentum. So let's try and read these letters. They're kind of hard to see, but in the first scenario, we have a car's velocity of negative 6.3, the driver's velocity of positive 6.3. Oh, that's equals. Sorry, they both equal 6.3. And we have the driver's mass of 100. In the middle picture, car's velocity is 0, but the driver still has its forward velocity, because remember, an object in motion stays in motion. So the driver still has 6.3, and the mass is 100. During the collision with the driver and the airbag, velocity of the car and driver are at 0. Driver's mass is 100. So we want to know how much momentum is absorbed by the airbag. Assuming that it's going to absorb everything, momentum equals mass times velocity. So the momentum of the driver, who has a mass of 100 and a velocity of 6.3, the airbag's going to absorb 630 kilograms meters per second of momentum. That's a lot. How does the airbag help decrease the force felt by the driver? Well, during the collision, instead of the driver hitting the steering wheel straight on, he's hitting the airbag. And the airbag's allowing him to have some cushion while he is falling to the steering wheel. So, force times time equals a change in momentum. If we increase our time, that means our force will have to decrease. That's why airbags are so important, because they increase the time of us colliding with the steering wheel. Again, if we're increasing our time, our force is going to decrease because they're indirectly related. The momentum's going to stay the same because that's what we're absorbing from the driver. That number can't change. So the only thing we can do is increase time. That's going to decrease our force. That's the same thing as we said with riding the punch. Remember, if you go along with the punch, you're going to increase your time of impact. So the force of the punch won't hurt as much. All right, number 64, what is conservation of momentum? Well, that states that momentum is neither created nor destroyed. It's only transferred. So we can't create or destroy momentum. It just doesn't magically appear and it doesn't just magically combust into nothing. It's transferred between objects. And finally, our very last question on this review. What types of collisions were talked about in momentum unit? List and define all three. Well, the very first one was elastic. And during elastic, we have objects apart. Then they collide. Then they move apart from each other. We also talked about inelastic. That's when objects are apart. Then they collide. And they stay together. They stick together. And they move as one object. And finally, we talked about recoil. In recoil, objects start together. Then, because of combustion or an explosion, we'll call it explosion, they move apart from each other. So that's kind of like a gun with its recoil from the bullet. So that's all we have to talk about for our reviews. Please make sure you study. It's not just enough to complete your reviews. You actually have to look over them and you have to read what you wrote. You actually have to study. If you have any questions, I'll be able to answer them before your test on your scheduled test date. If not, you're more than welcome to fill out the discussion board I left in your midterm exam folder on the first page of your Schoology account. Good luck studying.